Okay, in this video what we're going to talk about is how do we estimate the square roots of irrational numbers, specifically irrational numbers, to the nearest tens. This is tens. Okay, so when we say tens, we are actually estimating the square root up to the first decimal place. Okay, so for example, we're just estimating the square root until 8.3, so that is tens. Okay. So we usually use calculators in getting square roots of irrational numbers, but there is a way on how to estimate the square roots of irrational numbers without using a calculator. So for example, we have here, let's estimate the following to the nearest tens. This is square root of 40. The first thing that we're going to do is we are going to look at two integers in which square root of 40 lies. Okay? So let's think of two rational numbers in which square root of 40 lies. So if we're going to think of that, we have square root of 40 is between square root of 36. So square root of 36 is rational. Okay. Then after that, we have the square root of 40. Then right after square root of 40, we have another rational number which is square root of 49. So what does it mean is that square root of 36 is actually 6. Okay? So square root of 40 is greater than 6, but it's less than the square root of 49, which is 7. Okay? So in this case, what we're trying to do is square root of 40 is somewhat like 6 point something. We do not know yet that 10th place there. Okay? So that's what we are trying to do now. Square root of 40 is 6 point something, greater than 6, but it's lesser than 7. So what do? We count from square root of 36 to 49, and that's quite many. So square root of 36, square root of 37, square root of 38, square root of 39, square root of 40, square root of 41, square root of 42, square root of 43, square root of 44, square root of 45, square root of 46, square root of 47, square root of 48, and square root of 49. So our considerations are square root of 36, square root of 40, and square root of 49. So we are considering these numbers. So what we do is we express this as a fraction. So from 36 to 40, that is 1, 2, 3, 4, 5. 5 parts out of until 36 to 49. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 14 parts. So we are going to express this as fraction and convert this is in decimal. So we have 5 of 14. Okay? So again, this 36 to 40 is 5 out of 14, which is 14 is from 36 to 49. So 5 out of 14, if we're going to convert that in decimal, we're going to divide 5 divided by 14. We have 0, then we have another 0, then 5. We add 0, then we 50 divide 14, that's 0. How many 14 are there in 50? That is 3. And 3 times 14 is 42. Okay. Then we have 8. Then add another 0. So we need the hundredths place, because that's what we're going to use to round off. 80 divide 14 is, if we're going to do that, I think that is 7. Okay, 7. So 7 times 4, that gives us, let's just bring it here. 7 times 4 is 28. Then 7 times 1, oh, that's more than, so it's 6. Okay, so 6 times 14, simply, no, 14 times 6, simply 4 to 64. 14 times 6 is 4, then 2, 6, that's 84. It's still more than 80, so we get with 5. I think it's 5. 5 times 40 is, 5 times 4 is 0, 2. Then we have 70. So yes, 7. It's 5. Not 6, not 7, not 8. So it's 0.35. It's 0.35. Meaning, 514 is in the tens until hundreds place, it's 0.35. But we need only to round it off unto tens, okay? Because we're just looking for tens. So we need to round it off into tens. Therefore, 0.35 is just 0.4, because if 5 and above, we add 1 there. If 4 and below, we just copy, okay? So remember, if 5 and above, we add 1 to the next digit under consideration. If it's 4 and below, we just simply copy and make the next digit 0. Okay, so since 5, it's 5 and above, we add 1 to 3, that becomes 4. So our 5/14 into the nearest place is 0.4. So that gives us here, we just add it to 6 here. That gives us square root of 40 is just 6.4. So square root of 40 is approximately equal to 6.4. Next. How about if we have negative? So this one, it's a different value because it's negative. So what we're looking at is also negative numbers. Well, let's try to look at irrational numbers, which negative square root of 50 lies. Let's think of two rational numbers, okay? Or simply integers that negative square root of 50 lies. In this case, we have 64, square root of negative 64, and negative 49. Okay? So meaning, it's like saying that it's greater than negative, because this negative 64, that becomes negative 8, greater than negative 8, but it's less than negative 7. It's less than negative 7. So meaning, square root of 50 is like saying negative 7 point something, and we do not know that something. That's what we're trying to solve. So again, from here, we need from 49 to 50, okay? So if we're going to count from 49, okay, to 50, then until 64, okay? So from 49 to 50, we have 2 units, 49 and 50. Then from 49 to 64, we have 16. That's 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. It's 16. Meaning our fraction is 2 over 16. So that gives us 2/16, which is 1/8. And this is our decimal. Convert that into decimal. We will divide 1 divided by 8. And that gives us 0, 0, and 1. And that is 10 divided 8. That's 1. Then bring down again. We just need 2 decimal places. 20 divided 8 is 2. And that is 16. So we don't need to continue because we have already 2 decimal places, which is 0.12. Okay, 0.12. So 1/8 in 2 decimal places. This is 0.12, and we need to round it off to the nearest tens, which is this one. So let's consider this one 2, because that's the digit that we're going to consider if we're going to add 1 to the next to the left digit, or just simply copy. Since 2 is lesser than 4, we just simply have to copy 0.1. We don't need to add 1. And let's make the right digit 0. So 0.100 or 0.1, simply as that. Meaning, adding it here, negative square root of 50 is negative 7.1. It's like negative 7 plus negative 0.1. So negative 7. So writing last line, negative square root of 50 is just negative 7.1. So that is the decimal, that's the square root of negative square root of 50 into the nearest tens. Okay? So again, let's recall. Square root of 40, what we did is we identified first the 2 rational numbers in which square root of 40 lies. And that 2 rational numbers are square root of 36, which is right before square root of 40, and square root of 49, which is right after square root of 40. So we know that square root of 36 is 6, square root of 49 is 7. Okay, we're not considering the negative square roots because our consideration is square root of 40, that is positive. So we're just getting the positive square root of 36. So we know from this we know that square root of 40 is somewhat like it's greater than 6, but it's less than 7. Okay, so it's like saying 6 point something, but that something, the tens value there, that's what we're going to look at. So how do we look at it is we count from 36 to 49. So from 36 we express it as a fraction. 36 to 40, that is 5, out of 36 to 49, that is 14. And we divide that, our fraction now is 5/14. By division, we can convert it into decimal place, which is 0.35. And since we only need the tens, because we are just estimating the square root of 40 to the nearest tenth, we need to round it off. Since 5, the next digit is 5 and up, let's add 1 to 3. So that's 0.4. Meaning, square root of 40 is 6.4. In the second example, we have negative square root of 50. So, negative square root of 50, the right before that is negative square root of 64, and right after the negative square root of 50 is negative square root of 49. So, these are the rational numbers. So, you think for this first, in which the given lies. Okay. So, negative square root of 64, that is, since that is negative square root of 64 is negative 8, and negative square root of 49 is negative 7. This gives us the idea that negative square root of 50 is greater than negative 8, but it's lesser than negative 7. Okay? Meaning, negative square root of 50 is like negative 7 point something. We do not know yet that something yet. So that is why we need to count and express it as fraction from 49, which is the 49 to 50, that is 2, including 49. And from 49 to 64, that is 16, expressing 2 and 16 as a fraction. 2 as a fraction of 16, we have 216. And we simplify it, becomes 1/8. And when we convert it into decimal, it's 0.12. Since we only need the tens place, the ones place, the tens place here, the 1, digit 1, and the digit that follows is 2, and it's below 4, meaning we have to neglect that. We have 0.1, meaning negative square root of 50 now is negative 7.1. So how about if we're going to plot those in the number line? So since these are irrational numbers, square root of 20 is an irrational number, it's really hard for us to plot it on a number line, except if you're going to estimate this to the nearest tens first. So what we did before, we're going to use that so that we can put exactly, approximately these rational numbers in the number line. We can locate them in the number line. So our strategy is, let's rewrite it in a decimal form by estimating like what we did before. Then we use that decimal number to plot on the number line. Okay? So square root of 20, okay? This is between 4 and 5, because that's square root of 16, square root of 20. So it means that square root of 20 is greater than square root of 16 but less than square root of 25. So meaning we have square root of 20 is, because square root of 16 is 4 and square root of 25 is 5, meaning square root of 20 is 4 point something, and we do not know yet that one. That's something there. So that's why we need to count from 16 to 20 until to 25. So from 16 to 20, that is 16, 17, 18, 19, 20, 25. And from 16 to 25, that is 10. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, that's 10. So meaning the fraction, let's express 5 as a fraction of 10, that is 5/10ths, and that is 1/2. We know all that 1/2 is 0.5. Okay? So that gives us 4.5. Okay? How about square root of negative 7? Okay. Later on, let's finish first estimating number 2, the negative square root of 7. So negative square root of 7 is between negative square root of 4, 9, less than. So that's negative square root of 7. So it means that negative square root of 7 is greater than negative square root of 9. And we have negative square root of 4. Because negative square root of 9 is negative 3, and negative square root of 4 is negative 2. So this means that square root of negative 7, okay, square root of negative 7 is between negative 2 and negative 3, or negative 3 and negative 2. So this means that negative square root of 7 is negative 2 point something. We do not know yet that's something there, the tens place, the tens value. So that's why we need to write it in fraction from 4 to 7 to 9. Okay? So from 4 to 7, that is exactly 4. Then from 4 to 9, that is 6. Including 4. Okay, 4, 5, 6, 7, 8, 9. So expressing 4 as a fraction of 6, that is 4, 6, and we know that that is 2/3. If you're going to divide, you'll get 0.66. It's a recurring decimal. So in this case, 0.66, we only need the tens place. Okay, so we need to add 1 to this. We only need this tens place there, and therefore we will round it off. So that's going to be 0.7. So that gives our, this one, it's negative 2.7. Okay, so with this idea, we know that square root of 20 is 4.5, approximately 4.5. Negative square root of 7 is negative 2.7. We can now plot it on a number line. So if you have a number line, and this is our 0, this is our negative 1, this is our negative 2, this is our negative 3. So 1, 2, 3, 4, 5. So we have square root of 20. We're going to go back. That is approximately 4.5. Negative square root of 7 is approximately negative. So the symbol for approximately is like that. It's a curve equal sign. So negative square root of 7 is approximately equals to negative 2.7. So with this, we will use the decimal values to plot, and 4.5 is here, middle. And let's label it with, not with 4.5, but square root of 20. There. Then we have also negative square root of 7, that is negative 2.7, so that's here. It's almost negative 3. So it's 0.2 out on the left of negative 2.5. So this is negative 2.5 there, the middle, so that's 0.27 is somewhere here. Okay. And let's label it with negative square root of 7. Okay. So make sure to highlight that when we look at the number line, the points and the labels are very clear. So that's all. That's how we estimate the square root of a irrational number to the nearest tens. Okay. Then we can use that estimation to plot irrational numbers on the number line. Okay. So this one helps us to plot, because if you're going to use this raw number here, it's hard for us to locate that which part in the number line it belongs. But because we know how to estimate the square root into the nearest tens, that somehow gives us an opportunity to locate these irrational numbers on a number line. See you on the next video.